Here is the shock. Our Milky Way weighs about 1 to 1.5 trillion suns, and most of that weight is invisible. Around 85 to 90% is dark matter, a hidden halo holding the galaxy together. That is the main story, revealed in seconds. Now, why so heavy, and how do scientists know? From far away it looks like a calm spiral, a city of 100 billion stars. But the bright stars are just foam on a deep, dark ocean of mass. Gravity, from both visible matter and dark matter, is the anchor that keeps everything in orbit. 1.5 trillion solar masses means 1,500 billion suns. One sun already holds 99.8% of our solar system's mass. The Milky Way's mass equals roughly 500 quadrillion Earths. This weight makes our solar system circle the center, once every 230 million years. It shapes how gas collapses into stars and holds them in sweeping spiral arms. In space, mass is gravity's currency. More mass, more power to shape space-time. Now add what we can see. Stars, gas, dust. All stars together make only about 4 to 5% of the total mass. Gas and dust add roughly 1% more of the total. Planets, moons, asteroids, comets, less than 1%, almost a rounding error. A few percent more hides in stellar remnants. White dwarfs, neutron stars, black holes. The rest, the lion's share, is dark matter, about 85 to 90%. This vast halo is the true heavyweight behind that 1.5 trillion solar masses. Clue 1. Outer stars move too fast to be held by visible matter alone. Clue 2. Dozens of satellite galaxies orbit a mass much larger than the visible disk. Clue 3. Background light bends more than visible matter can explain. Like city lights on concrete and steel, stars are just the decoration on a massive structure. We live inside this halo, moving through it every second. So how do scientists weigh a ghost? Let's investigate. The Milky Way holds about 200 to 400 billion stars. Yet all those suns add up to only 4 to 5% of the galaxy's mass. Gas and dust, the raw material for new stars, contribute about 1% of the total. So where is the rest of the mass? A few percent sit in stellar remnants. White dwarfs, neutron stars, black holes, planets, moons, asteroids, comets together are less than 1%. A huge shortfall remains, that is the dark matter. Far from the center, stars should slow down. But observations show they stay fast. To keep them bound, extra gravity is needed, which means extra unseen mass. The Milky Way rules dozens of satellites, including the large and small Magellanic Clouds, track their speeds and paths for millions of years. Faster orbits mean a more massive Milky Way. These measurements point again to about 1.5 trillion solar masses. Mass bends light. Our galaxy's halo subtly warps background galaxies. Measure the distortion and you can calculate the halo's mass. Star speeds, satellite orbits, and bent light all agree. A massive invisible halo dominates. Computer simulations only form stable, spiral galaxies like ours when dark matter is included. This is the power of science, measuring what we cannot see by what it does. Dark matter does not emit or reflect light and seems to interact only through gravity. Around the world, deep labs and accelerators hunt for a dark matter particle. Finding it would solve the missing mass puzzle and reshape fundamental physics. When looking up at the Milky Way, remember, we ride a luminous carousel inside an invisible giant. The galaxy's hidden mass writes the graceful dance of the stars and our place within it. Want more daily cosmic adventures? Subscribe to Universal Universe, share, and like. Then let's keep exploring the invisible.